Okay, take two. Sorry, I pushed the wrong dealie and it interrupted the video recording. So this is part B. So anyway, so as I was saying, so we already found the base. The base is this dealie right here. This is the base. We just multiply that by the height. I think it'll be golden. So that times the height of 22. Let's see what we get. I get 561 or 569.901. I'm going to look at the answer key, make sure that's right. That is correct. Haha. That was really tough. I'm going to be honest. That was a tough question for them to throw at you because I don't think we saw anything quite like that on the in the practice work where they had you really think creatively. I mean, like I said, you could have found it by piecing the composite solid together, that it's one solid minus another solid, but that's the shortcut that will save you many minutes on the when it's game day. Hokey smoky. Number 11. I'm like way over my test time, but he's okay. Numero 11. A pharmaceutical company makes medicine capsules in the shape of a cylinder with two hemispheres at either end. Two hemispheres. Two hemispheres equals one sphere. Easy peasy. As shown in the diagram, the diameter of the hemisphere is 6.6 millimeters and the height of the cylinder is 12.5 millimeters. What is the volume of the capsule to the nearest tenth? Guys, we just have the volume of a cylinder plus the volume of a sphere. We just have to make two calculations and add them together. So 6.6 millimeters diameter makes the radius 3.3 millimeters. So the cylinder, the volume is pi r squared h. The r is 3.3, so 3.3 times 3.3 is 10.89. Times the h times the pi. The h is 12.5. We get, good night. They say round it to the nearest tenth. I'm going to do that starting now. 427.4. That's the cylinder. Now we have to find the two hemispheres, which is basically the same as one sphere. Easy the peasy. So that would be the volume of a sphere equals memory 4/3 pi r cubed. Because there's the 4. Every sphere has a 4 in it somewhere. And the volume has the thirds and the cubed in it. Why can't I draw a halfway decent 4? We'll do it like that. Whatever, you know what it is. Okay, once again, the r is still 3.3 millimeters. I'm going to plug this into my calculator. 3.3 cubed is 35.937 times 3.14 equals that, times 4 equals that, divided by 3 equals that, 150.5. We're going to round that up, so equals 150.5. Add those two numbers together. I didn't line them up very nice, but we get 97755. 577.9, I think, is my answer. And that answer would be correct. Cubic millimeters is the volume of this doojobby. These little capsules. Last one, guys. Number 12. I know what you're thinking. I'm sad that it's over too. A cone was removed from a cube with an edge length 12 centimeters. Sweet. The height of the cone is also 12 centimeters. So the cone touches top and bottom. And its radius is 5 centimeters. Find the volume of the remaining solid. So how much cube remains once we slice out some cone? How in the world do you remove a cone from a cube like that? You must have a special drill bit, I guess? Whatever. Maybe it's a, I don't know, whatever. By some weird sorcery and witchcraft or marvel of modern technology. So the volume of the cube, you guys remember the volume of the cube? You take the edge length and you cube it. So 12 times 12 is 144. Times another 12 is 1,728. So that's our starting volume. That's our starting volume of the cube. Now I have to figure out what was taken away. A cone was taken away. So the cone is 1/3. I will never forget that 1/3 again. 1/3 times the pi r squared, the circle, times the height. And so the radius is 5. 5 squared is 25. So 25 times 12 times pi divided by 3. 314. Subtract that cone from that cube. 1,728. We get 1,414. And since it's volume, we're dealing with centimeters. Nope, I said erasify. Centimeters cubic. Let me double check my answer. 14 centimeters cubic. Guys, I only missed one on this checkpoint. But I don't think if I was actually taking that checkpoint, I don't think I would have actually missed it because I would have realized, hey, let me take a look at this again because that decimal looks wrong to me. Oof. I hope I can figure out how to splice those two videos together. We'll see. Anyway, love, joy, and peace. When you're ready and you feel prepared, you may take the real checkpoint. Otherwise, if you found that one of those pieces was really difficult, you may go back and review the chapter where we did that. I know composite solids are really tricky, and it seems like they did, what, 3 composite solid problems? And they were big. So, yeah. Look what we did, guys. This is pretty fun. Oh, man. More fun than a math teacher ought to be allowed to have, if you ask me, but you didn't. All right, I'm going to try to see about splicing videos together. Otherwise, I'm sorry, but this is in 2 videos because I accidentally clicked the end recording. Jobby. But love, joy, and peace. I am here for you. Bye-bye.